if g of x is always smaller than h of x, so can you picture that? Like f is a function that's on the bottom, g is a function that's in the middle, and h is a function on the top. That's why they call it the sandwich. So you've got a lower and an upper and then a middle. Okay, so they call it sandwich then. So if that is true, okay, yeah? Okay, yeah, they could also be equal. So imagine, here I'll draw you like a little sketch thing. So it could be like something like that, and something like this, and then this one is always in between, no matter what. So they might be really close together for part of it. So you've got your f of x on the bottom, you've got your h of x on the top, and no matter what, g of x is always in the middle. Okay, that's true. All right, so if you've got that, that's your hypothesis, if and if. Okay, then if you can prove the lower limit as x approaches a of f of x equals L. So if you can prove the limit of the f function, and if you can prove the upper limit, and so the upper limit would be of the h of x function, limit as x approaches a of h of x also equals L. So if you can prove the lower limit is L, and you can prove the upper limit is L, then what can you conclude about the middle function? It has to be L, right? There's no other, I mean, if one's L and the other is L, and the only choice is to be either between or equal, then it has to be equal, okay? Then it is proven that the middle limit, g of x, is equal to L also. That is the sandwich theorem. So you prove the one on the bottom and you prove the one on the top, and if those are the same thing, then you've proven that the middle must be there, must be that value also. All right, that is the sandwich theorem. I'm just going to put a rectangle around that to highlight that, and we'll do maybe 2 sample problems proving that. Okay, here's our first one. All right, find the limit as x approaches 0. No, as x approaches infinity. Of sine of x over x. Okay, when you're working with a function where you're trying to prove it and it's like a combination, like you've got a trig and you have a linear on the bottom. You've got 2 different things. Always just kind of focus with the trig one, because the value of sine has boundaries, right? Sine, can you picture what sine is? What's the lowest that sine will ever be? Right, never lower than -1. And what's the highest that sine will ever be? Okay, so we start with that. All right, so we start with the fact that sine of x is between 1 and -1. And so do you see how now you have set up a lower function, a higher function, and a middle central function? Okay, so that's your job, is to start with that. You got to start with something that's in order and that works. Okay, so we know that to be true. Now we want to experiment. What happens if you divide that by x? So now divide sine of x by x. Well, if you divide the middle function by x, what else do you have to do? You got to divide the upper function by x, and you have to divide the lower function by x. So whatever you do to the middle, you have to do to the outsides. So now you want to prove what's the limit of the lower, and then you want to prove what the limit of the upper is, and then hopefully you'll be able to figure out the limit of the middle. All right, so we're going to do the lower limit. And so the lower limit is what's the limit as x approaches infinity of 1 over x? And we all know the answer to that, because if you plug in infinity into 1 over x, what do you get? You get 0. Oh, sorry, I'm doing the lower one. It's negative 1 over x. So what do we get? 0 minus, because it's a negative number. Okay, and then the upper limit, the limit as x approaches infinity of positive 1 over x. Well, if I plug positive infinity into that, I get 0, but I get 0 as a positive number. And so then what's the middle limit have to be? If the lower limit is 0 minus and the upper limit is 0 plus, what's the middle? Just 0. Okay, so therefore, the middle limit as x approaches infinity of the center function, which was sine of x over x, has to be 0. There's no other option, because since it has to be between, it has to be 0. Okay, let's try another one. Any questions on that one?
You just say due to the sandwich theorem?
Yeah, according to the sandwich theorem. Now, technically, if I was writing this out, all important, what has to be true, the very beginning of the sandwich theorem, what has to be true about all three parts? They all have to be continuous. Well, is sine continuous? Is the number 1 continuous? Was the number negative 1 continuous? Okay, so we were all fine. All right, let's try. All right, find the limit of 1 minus sine of x over x as x approaches infinity. So you're going to start with the exact same thing because it has a trig thing in it. We're going to start with that. Okay, so we're going to start with sine of x between negative 1 and positive 1.
More minus sine x, or?
Nope, just starting with sine x. Now you're right, because this is true. We start with sine x. Now, we want to make it 1 minus sine x, right? Because that's what's in. We're starting with something that is a true statement. We need to convert this now. Do we divide by x, or do we do the 1 minus sine x first? What's legal? We have to do the 1 minus. So if I do 1 minus sine x in the middle, what do I have to do on the other sides? I have to do the same thing, right? I have to do 1 minus 1. And I have to do 1 minus negative 1. So I have to do 1 minus. Basically what I was doing is I was putting a 1 minus here, and a 1 minus here, and a 1 minus there. You're putting a 1 minus into all of those, which is going to simplify. So what is the lower boundary now? 2. And what's the upper boundary? 0. Okay. Now what algebraic thing do I get to be working towards the limit I need? Divide by x. So now divide all of that by x. And now you want to prove the lower limit, the upper limit, and then see what the middle limit's going to be. So the lower limit would be the limit as x approaches infinity of 2 over x, which, just like we did before, is going to turn out to be what? 0 plus, because 2 is a positive number. Okay, the upper limit we have 0 over x. Okay. Ooh. What if we plug in infinity to that? 0 over infinity is not 0. What do we? Oh, It is different, it is indeterminate, which I don't think Trung knows yet. Okay? Yeah, so we have to take the derivative of both of them. Okay? So that's, and whose rule? It was named, it was a funny French guy, L'Hôpital's rule. Okay, so all that means is if it comes out to be that, 0 over infinity, what else is indeterminate? 0 over infinity, 0 over 0, infinity over infinity. Those are all indeterminate. So now we just take the derivatives of the top and the bottom. So we're going to use L'Hôpital. What's the derivative of 0? It's just 0, it's a constant. And what's the derivative of x? 1. Okay, what's 0 divided by 1? Is that indeterminate? No, that is not indeterminate. What is that? That is 0. 0 divided by anything is 0 as long as it's not being divided by 0 or infinity. All right, so we just proved that the lower limit was 0. We just proved that the upper limit was 0. So that means that the middle limit has to be 0 as well, according to the sandwich theorem, because everything was continuous. So that helps us prove that 1 minus sine of x over x does also have a limit of 0. Okay, that was all I needed to show you today. The rest of your homework is going to be finding limits from graphs and finding limits algebraically. So proving a limit. So I want you to remember, when you prove a limit, use factoring to prove a limit. Okay, use division to prove a limit. Text me or email me if you have any questions. Do me a favor. Don't spend any more than like 45 minutes on this homework. If you get to more than 45 minutes, just stop and then tell me tomorrow that because I don't want you to spend longer than that. So it's been a couple. Well, I just need to know. I need to, since it's been 3 years since I taught this, I need to make sure I'm not overloading you, because I'm like, oh, they remember this. This should be easy, but maybe maybe it won't be easy for you because maybe everything is a little not quite as quick as it should be. So don't spend more than 45. If you get it done in less, great. Okay? All right, that's it. Hopefully you go through the homework pretty quickly. Do you guys still have your group chat thing from last year? We should form a new one with just, even you could put Brennan and Blake in there too if you want, but.
They're the ones who always answer.
What?
They're the ones who always answer and help.
Oh, they did? Yeah, so you should definitely, you could get one going again with everybody. All right, so let's see.
See, I never like saved your guys' name